We've got the video now for the Williamson circuit, which was first introduced in the Wireless World April 1947 edition. This circuit is a triode push-pull with negative feedback of 20 decibel. It's a Class A design and 0.1% distortion figures can be achieved. And for 1947, that set the standard for the international market. In the near future, we're going to cover the upgrades of the Williamson circuit, which featured up to the 1952 period with the Wireless World editions, and look at the Dynaco Stereo 70, the David Hafler design, which was an improved version of the Williamson.
This is one of the most famous, if not the most famous, valved amplifiers of all time. As with many a good idea, it is basically very simple. So it was a GC design, and you will find it in the book that I have previously referred to, and that is An Approach to Audio Frequency Design by GC/MOV. That book also contains a number of other amplifier designs, starting with a single-ended amplifier and going up to certainly, no, it wasn't 400 watts with KT88s. In fact, there's a DA100 amplifier at 1200 watts, not hi-fi, it's Class B. And it also has several pre-amplifier circuits in. So, the amplifier we have here, as I said, it's basically quite simple. So it's a power amp only, with fairly low input sensitivity, 1.9 volts approximately RMS, with about 15 dB of negative feedback. It uses two double triodes and two KT66 beamed pentodes, triode connected. So, as is typical of GC designs, it uses a directly coupled input stage to the phase splitter, and the phase splitter is the very simple split load phase splitter. Now, feedback is applied, as is almost always the case, to the cathode of the input valve. So there's the feedback input there, there's your signal input there. There's no DC blocking, so you need to make sure there is on the output of the preamplifier. There's a little bit of phase correction in the form of this capacitor in series with this resistor across the anode load. The anode supply is heavily decoupled by an 8 microfarad there and a 33k up there. The DC voltage is chosen to be appropriate to apply directly to the grid to give about halfway up between the cathode voltage and the anode voltage here, so that there's enough volts across this triode for it to be able to swing negative and positive without distortion to drive the following stages. Now, the output impedance is always fairly high on this kind of phase splitter, and you're not going to get a great deal of voltage swing in either direction because it is having to do two lots, one on the anode, one on the cathode. So what they have done is have another voltage amplifier stage afterwards, another double triode, shared cathode resistor which gives negative feedback for any imbalance in the signal. Very straightforward. Then we've got an anode load for 47k. This is quite capable of driving the following grid resistor, which is 3 times its value. Quite small coupling capacitors. This improves stability at the low frequency end and prevents motor boating, or is one of the ways of preventing motor boating. The output stage, it's got grid stopper resistors as is typical. Now, you've got two resistors in the cathode. One of them allows balancing of the current in the two valves, and one of them sets the total quiescent current, which is R22. There is then a fixed bias resistor. It's important to limit the range of adjustment to prevent disasters on misadjustment with excessive current. As I said, these are triode connected, and they have put grid stoppers in the screen grid circuit. Being triode connected, obviously it's not ultralinear, so it's a very straightforward output transformer. Notice no stabilising components across it, nor is there any stabilising capacitor across the feedback. The only one was the one I previously mentioned up here. Williamson points out that the primary determinant of the quality of a valved amplifier is the quality of the output transformer. The rest of the circuit, unless it's incompetent, doesn't have a great deal of effect. This was a very straightforward circuit. There is a little bit of awkwardness in getting the currents adjusted in the cathode. So you couldn't just build this, you did have to do some measurements to get the current balanced. But apart from that, there's very little to it. Now the power supply. Notice there are two chokes. There is a 10 Henry at 150 milliamp, which is the main smoothing, coupled with small capacitors, C10, it's only 8 microfarads, and notice that it's a paper, not an electrolytic. But notice that the smoothing capacitor, also 8 microfarads, is the cheaper and smaller electrolytic, and an electrolytic is also used for the one I've already mentioned to decouple the input circuit. The reservoir capacitor takes most of the ripple current and is subject to the surge at turn on most, and therefore they have used the component that's likely to have the longest life in the reservoir capacitor position, the paper, but the others quite adequately electrolytics. Nowadays electrolytics are so good that you could use electrolytics for all three, very low ESR, very low leakage, and if you buy from a decent make, very long life. This amplifier operates in class A, it should be noted. Therefore there's very little change in current with the swing of the signal. It does in fact give the currents there from 62.5 to 72.5 per valve. Being class A, obviously it dissipates a lot of heat, whether it's producing the output or not, and in fact the dissipation goes down as the output increases. This is only a 15 watt amplifier. However, that is very adequate for driving speakers of reasonable efficiency and deafening if they have good efficiency. So it was perfectly good. The thing about it was the distortion was less than 0.1%, which is the important thing here. And although they don't quote a separate figure for intermodulation distortion, it too would have been low. It's effectively an all triode amplifier because the pentodes are triode connected. They use a directly heated rectifier. GC were not keen on making indirectly heated rectifiers, which is why you were stuck with something from their line. Obviously they were not going to recommend a Mullard rectifier, and most of the Mullard ones were directly heated as well. A GZ34, or better still a 33 or a 37, would replace the 5U4 or the U52, being indirectly heated. Note also that they show neither switching nor fuses. Well, if I had one of these amplifiers, I would certainly add a mains fuse to protect against disaster, and I might even add one here in the HT to, again, should there be a short that wasn't enough to blow it on the main side, to take it out on the HT side. They don't show a mains earth. I would add one, but I would earth the chassis if the transformer had an electrostatic shield, and this one isn't shown as having one. I would earth that both of those directly to the mains, and then put a resistor between 10 and 100 ohms between the earth for the circuitry and the chassis, thus breaking a hum loop with the preamplifier, should that have a separate earth return somewhere else. But that is the Williamson, as I say, probably the most famous valve design ever.
Outside it's cold and inside it's warm. Well, up here all day I'm gonna stay, but never go down, 'cause I fear to leave this place, 'cause I fear to go out in the world. It's bringing me, bringing me, bringing me, bringing me down right now. And you're twisting me, turning me, spinning me around somehow, while the world goes by and I'm